All right, so yesterday we talked about areas of different types, or not yesterday, but the day before, we talked about areas of different types of polygons, such as trapezoids, parallelograms, rhombus, kites, so on and so forth. And at the very end, we kind of briefly talked about the area of circles, and we talked very briefly about the circumference of circles, okay? And so just to reiterate what the circumference is, it's essentially the distance around the circle. So think about it like the perimeter of a circle, except for we don't have straight lines, so it's not just simply as adding up all the dimension or all the line segments, so on and so forth, that make it up, right? So we can, so the ratio between the radius of a circle and its circumference is pi, and that's where that number comes from, 3.1415927, so on and so forth. Okay. So the way that we can calculate the circumference, since we know what the ratio is we use the formula 2 pi r, or diameter times pi. Okay, so that's what this d here means. And again, we didn't really talk about d times pi. This is the one that I prefer us to use. Okay, and that's just because most of the time we're going to be given a radius instead of the diameter. But in case we have the diameter instead, it's just simply the same as diameter times pi. Okay. All right. So again, for all circles, the ratio of the circumference to the length of diameter is the same, pi. This is kind of what I was just saying before. So for area, though, all right, our formula is pi r squared. And again, it takes a little bit of essentially calculus to kind of really explain where that comes from and why that is. Okay, so we're just going to save the why it's pi r squared and go more into, okay, we understand this, let's use this. Okay. So what I want us to do first, kind of just getting, again, because I know you've seen all these formulas before, is I kind of just want us to get a sense of how to use this type of thing. So I'm going to give you guys about 2 to 3 minutes, so kind of consider this a warm-up. And I want you to try and complete this table, okay? So how this really works is I'm given one piece of information. I'm either given the radius, the diameter, the circumference, or the area of my entire circle. And using that information and using the formulas from above, right, I want you to try and essentially work to find the rest of the pieces of information. Okay? So for example, in number 1, right, we know the diameter is 10. Okay? So if the diameter is 10, what does that mean the radius is?
5.
It's 5, yeah? My radius is 5. So another little formula that you can kind of think up here, and then this is nothing to do with area or circumference or anything, is that my radius is equal to half my diameter, or another way of thinking about that is my diameter is equal to twice my radius. Okay, whichever one you want to use or feel comfortable using, they're both the same thing. Okay. So if I know my radius is 5, my diameter is 10, what's my circumference? And we want to leave it in terms of pi. You don't want to calculate this out as in like 3.14159 times whatever. So if my radius is 5, my diameter is 10, what's my circumference? That's exactly what it is. My circumference is 10 pi, okay? And I'm just going to kind of, where's my thing here? You don't have to show the work for each one, but it's because my circumference is equal to 2 pi r, or diameter times pi. We know my diameter is 10, so my circumference is equal to 10 pi, okay? Now my area, right, so again, you can kind of think this as radius is equal to 1/2 the diameter. Diameter is equal to 2 times the radius. Circumference is equal to 2 pi r, or diameter times pi. And my area is equal to pi r squared, okay? So for this one, right, what would be my area?
Would be 2 times pi times radius times 5, basically.
2 times 5 times...
No, 2 times pi times 5, which is the radius.
2 times pi times radius?
Yeah.
So it's pi r squared, okay? So this would be pi r squared, which is equal to pi times 5 squared. And 5 squared is 25. So this equals 25 pi. And again, we're leaving it in terms of pi. I don't need to calculate that part out, okay? And so that's my area. So again, I'm going to give you a couple minutes and I want you to try and finish the rest of this table. All right. Are we good, or do we need another minute? We need another couple minutes? Okay. To understand number 3 and 4 might be a little bit harder. Okay. So just a couple more minutes. By the way, an update, I apologize for the flickering. I just got an email, they're gonna look into it, so hopefully we'll know soon. I apologize. If it bothers you, you can go onto Zoom instead and look at it from there so you don't have to see it, if it bothers you. Alright, it looks like we're mostly ready. So let's go ahead and start with number 2. So if my radius is 3 rad 5, what is my diameter? 6 rad 5, right? So 3 rad 5 times 2. So this would be 3 rad 5 times 2, which is equal to 6 rad 5. Okay? Now, if my diameter is 6 rad 5, what's my circumference? What? The same? What are we missing in here? Well, the pi, right? So remember that this is diameter times pi, since my diameter is 6 rad 5. Right, this is going to be 6. And now the way that we write this is a little bit more different. Right? We're always going to put the pi in front of the radical. Okay? So it would be 6 pi rad 5. Okay. Now our area is going to be a little bit trickier. Okay? Since our radius is 3 rad 5, right? Our area is going to be the same thing as pi times 3 rad 5 squared. Okay? What's 3 rad 5 squared? All right, remember one of our rules for exponents, if I have a times b to the nth power, this is the same thing as a to the n, b to the n. Okay? Meaning that this is going to be pi times 3 squared rad 5 squared. Okay? Which equals 5 squared is 5, or rad 5 squared is 5, 3 squared is 9, so this is actually going to equal 45 pi. For number 3, we kind of have to work backwards here a little bit, okay? So if my circumference is 36 pi, right, my circumference could be thought of as either 2 pi r or d times pi, right? What is my diameter going to be? So let's work backward that way. What's my diameter?
36.
It's going to be 36. And if my diameter is 36, what does that mean my radius is? 18. It's half of it, okay? So now, what's the area of this guy?
324.
What's that?
324.
324 pi. 324 pi. Okay? That looks ridiculous. Hang on. All right. What about for number 4? All right, so if my area is 75 pi, okay, how am I going to find any of these pieces of information? Okay. So again, I understand that this one's harder. Remember that this is equal to pi r squared. Okay? Which means that if I divide both sides by pi, that means r squared is equal to 75. If I take the square root of both sides, I get r is equal to the square root of 75. Oh, sorry, I wrote 25. 75, which when we simplify it out, what's that? 5 rad 3. Perfect. Okay. So my radius is going to be 5 rad 3. Okay. My diameter then is double that, so it's 10 rad 3. And then my circumference is diameter times pi, so 10 pi rad 3. Okay. So again, so basically what we just tried to show here is given any one of these pieces of information, you can always tell what the other three are. You can always come up with the circumference, the diameter, the area, or the radius, depending on which one you're given. Okay. So using a calculator, find the circumference and the area of a circle whose radius is these three, so A, B, C. So we're going to do this one together, okay? So, again, it wants to use a calculator because it wants to give us approximate. I don't like using approximate. I'm going to use exact, okay? So, if so this tells me that R is equal to 14, okay? And all it's trying to wants is the circumference and area. So remember that circumference is equal to 2 pi r, since all we're given is the radius, and the area is equal to pi r squared. Okay? So for A, my circumference is going to be equal to 2 pi times 14, which is going to be equal to just simply 28 pi. And again, I'm not going to go ahead and solve it out that way, or I'm not going to expand it. And then my area is going to be equal to pi 14 squared, which is equal to, I don't know 14 squared off the top of my head, is equal to 196 pi. Okay. For B, all right, for B. Now the difference between B and C is I have a variable in there, okay? So in order to solve this, I know that my radius is equal to 3x, okay? So my circumference then is equal to 2 pi times 3x, right? Which is equal to 6x times pi, okay? Now, there's really nothing I can do to kind of solve for that necessarily, okay? So, what I'm going to do now is find my area, which is equal to pi times 3x squared. Now, remember this rule. If I have the parentheses, a times b to the nth power, it's the same thing as a to the n, b to the n. So this actually becomes 9x squared times pi. Okay? Any questions? So, understanding that, do number 7 for me. I said number 7, I mean part C. Sorry. Still a bit early. All right, what did we come up with for the circumference?
14y.
14y times pi. Okay. What did we come up with for the area?
29y.
49y
Times pi.
squared times pi. Okay? Because we forgot to remember, if we do 14y squared, it's 14 squared times y, or sorry, if we do 7y squared, it's 7 squared times y squared. Okay? All right. Any questions on this? All right. Now, another type of problem we might have is find the diameter of a circle whose area is 58 square inches. Okay? So I know that my area is equal to 58 inches squared. Okay? But again, we know the formula for area is equal to pi r squared, and we also know that the diameter is equal to, wow, I almost put half the radius, jeez. Diameter is equal to 2 times the radius, okay? So we kind of have to do this in a couple of parts. So we're going to, so essentially we're going to have, find the radius first before we can really find the diameter, okay? So let's go ahead and do that, okay? So if I know my area is 58 inches squared, right, I know that this is equal to pi r squared, okay? So yes, we are going to have to use our calculators for this, okay? So what I'm going to do is I'm going to divide both sides by pi, okay? I'm going to get the r squared, and yes, I'm going to use approximate. Where's my calculator go? There you go. I go 58 divided by pi, which is approximately 18.46. I'm just going to go 18.46. Okay? Going back. So r squared is approximately 18.46, which means if I take the square root of both sides, I get r is approximately, that's my answer, so I'm going to do the square root of answer, approximately 4.3 if I'm rounding to the nearest hundred. Okay. My radius is approximately 4.3 inches. Okay, but again, we're asked to find the diameter, right? And so my diameter is 2 times 4.3, which means my diameter is approximately 8.6 inches. Okay. Any questions? So again, that's just kind of how we can use the area and circumference and stuff in order to tell a lot more about circles. And again, we'll get more practice with radius and diameters and stuff like that of circles a lot later. Okay. But now, kind of the reason that we want to be able to remember all this and kind of have mastery of that is we're going to talk a little bit about, okay, what happens if I only want to find the area of part of a circle? Okay. If I only want to find the area of part of a circle. Okay. So some things, some key definitions that we need to talk about first, right, is what a central angle is, because that's how we're going to determine it. All right, so a central angle is an angle that intersects a circle in 2 points and has its vertex at the center of the circle. Okay. So in this example, or sorry, in these pictures down here, it's green, right? This angle right here would be my central angle. Okay. So if that's my central angle, right? But we also understand, I mean, we have 2 different real parts of it, okay? This part right here, and again, we'll talk way more about this later. If I wanted to find this part right here, right? this would be 360 minus that central angle. Okay. Again, we will talk way more about that later, but just for right now, understand that if I wanted to find the other half of that, right, that's how I might do that. So again, sectors aren't just limited to acute angles, right? They can be very massive, right? So, what a sector of a circle, all right, it's a region of a circle bounded by a central angle and its intercepted arc. So it's a part. So there's actually two ways that we can think about this. As if I'm given this central angle right here, right, then the sector of the circle would be all of this, right? Now, if I'm given this angle right here, and I want to say use that central angle, because again, it's the opposite side, right? It's still, by definition, it's still the same thing, so I can actually consider this a sector of the circle as well. Okay? So there's really two kind of parts for it. Oh my gosh, whoever typed this. So if I want to find the area of a sector, okay, so kind of think about it this way. Remember that degrees, right, the very definition of what a degree is, right, it is a 1/360th of a circle, right? So if it's 1/360th of a circle, right, that means it's really one portion of a circle. Okay? So you would have to imagine here, and kind of why this idea works, is if this is like, you know, X amount or theta amount of degrees of the 360, right, then wouldn't it make sense that if this was my whole circumference, or not circumference, if this was my whole area of the whole thing, wouldn't it cut it off proportionally, just as proportionally? Wouldn't be this exact same representation of one part. So I mean, think about it this way. Let's just say I had a circle and I had exactly 1/4 of this thing, right? I had 90 degrees. That's 1/4 of 360. Wouldn't the area of that sector be 1/4 of the area of the entire thing? And that's exactly how this works. Okay. So, in order to find the area of a sector, so we'll use red for that, right? We compare the area of the sector. If we compare that to the area of the whole, it's going to equal the exact same ratio as the central angle, and I'll use theta, compared to 360 degrees. Okay? Now, the equation that you might see if you kind of use it online is the area of the sector is equal to pi r squared times theta or x over 360. I personally don't like using that one. I would and it'll make sense later, I would much rather you guys use this proportion and then solve it out that way. And the reason why is it makes it easier let's just say if I knew the area of the circle, or the area of the sector, I knew the central angle, find the area of the whole circle, I could do it using the proportion instead of the equation. Okay? It just saves me a little bit of legwork. Okay. All right. So here's an example. A pizza has a diameter of 9 inches and is cut into 10 congruent slices. That means, and again, I'm using green. I'll use red from here on out. That means each, as I draw on pepperoni, which just happens to be red. Okay. Let's use a different color. Let's use blue. Okay. Which means that this angle, 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 and this angle, and this angle are all congruent. Okay? What is the area of one slice of pizza to the nearest hundredth? Remember that this thing has a diameter of 9 inches. Okay? So how are we going to do this? Right? Remember, we're going to use the proportion, the area of the sector, right? The area of a slice. I'll just even write that slice compared to the area of the whole, which is pi r squared, is equal to the degree of the central angle out of 360 degrees. Okay? We know that the diameter is 9, right? The diameter is 9. Since the diameter is equal to r, what does that mean? And the diameter is 9. That means that the radius 4.5, or for now I'm just going to use 3. I'm going to use 9 over 2. Okay. So that's just the radius. Okay. Now, if it's 10 congruent slices, right? What do you think each one of these, the degrees of these things are going to equal? The central angles of each of these slices. What do you think they're going to equal?
9/10 of an inch.
Say that again?
Maybe 9/10 of an inch.
9/10 of an inch?
Yeah, because there's 10 slices and the whole thing is 9 inches.
Right, so the diameter. So that would be how it might. So what you're saying, explaining right there is this whole thing is 9 inches,
Yeah.
right here. But I'm asking, what's the length of this thing right here?
Oh.
Right. Well, it's 1/10, right? Because each one of these, this is 1/10, this is 1/10 of 360, this is 1/10 of 360, this is 1/10 of 360. What do you think each of these degrees equals? It's 36, right? Each one of these angles is equal to 36. So my central angle, right, is equal to, another way if you can think about it is 1/10 of 360. So each central angle is equal to 36 degrees. All right, so now I have my central angle, I have my radius. I'm kind of ready to put it all into the equation. Okay? So, again, we're trying to find the area of the slice over pi times 9 over 2 squared is going to equal 36 out of 360. Now, before I actually go on, and again, you can kind of see this, again, I wanted you to set up the proportion this way, but you'll see that the right-hand side is still going to reduce to what? 1/10, right? 1/10 of the circle, so it still works the exact same way, okay? So, another way is, area of the slice over, and then let's just do 9 over 2 squared, which would be 81 over 4 pi, is equal to 1/10. Okay. Now, in order to solve this, I have to use my cross product property. Okay. And I go 10 times the area of the slice is going to be equal to 81 over 4 times pi. Okay, and don't worry, we will calculate this out because 81 over 4 pi, it's messy, right? Because now what I need to do is I also need to divide by 10. Okay, so let's go ahead and turn this into a fraction first. So 81 divided by 4 times pi. So 81 divided by 4 times pi, which gives me about 63.62. 63.62. So I know that 10 times the area of the slice is about 63.62. Okay. So now if I divide both sides by 10, right, I get the area of the slice is equal to about, I'm going to do about here, 6.36 inches squared. Okay. Any questions on this? Right? Makes sense? So now, that's using if I want to find the area of a sector. What happens if I want to find the length of a sector? Okay? So given the exact same idea, right? Except for now, instead of working with area, we're working with circumference, right? The exact same thing is going to hold true. So if I imagine, so if this is what we call our arc length, or L. If I want to think about what the length of just this portion here is, right? And if I think about the circumference of this thing, right, it's going to be the same ratio. This length, right, is getting opened up to by x degrees. This one is getting opened up to by 360. Okay? So it's going to maintain the exact same proportion, just like the area of this, right, is proportional to, or the area of this to the whole area is proportional to the degree of the central angle to 360. Right? So some key things to think about is sector over whole is equal to central, or sector over whole. Okay? It's kind of the best way to think about it. So no matter what, right, whenever you're trying to set up these proportions, that's kind of the way that you should think about it. So arc length then, right? Since my my formula for circumference is 2 pi r, right? The arc length L over the circumference, which is 2 pi r, is equal to my central degree, or central angle, over 360. Okay. Now again, the equation that people give you for arc length is they just multiply the 2 pi r over, right? But again, I prefer you to use this one, right? Because it'll actually help you, right? Because we can even extend this out to be, well, this is going to equal my area of my slice over pi r squared. So all three of those are actually equal. So I can use any sets of those, right, in order to solve for any pieces. Okay? So that's why I prefer you use this one, the top one. So here's an example. Okay? Find the length of arc ZY. So again, I know that's terminology that we haven't gotten to yet, but this right here is read as arc ZY. Oops, I put the arc ZY. All right. So how this is going to work, okay? I'm going to do A for you, then I want you guys to try B, okay? That's weird. Okay. So for this one, I know the formula that I'm using is L over, and RL would be the measure of arc ZY. Over 2 pi r is going to equal theta over 360 degrees. Okay? Well, let's fill in the piece of information we know. That this is telling us that our r is equal to 4 inches, and our theta is equal to 75 degrees. And that's what the picture tells us. So now let's apply it to what we know. So I know that the measure of arc ZY over 2 pi times 4 is going to equal 75 over 360. Okay? So kind of just take another step. Measure of arc ZY over 8 pi is going to equal. So now what's 75 divided by 360 as far as reducing fractions? 75 divided by 360. What's that? No, I don't want a decimal right now. I want to try to keep it as fractions. is going to equal 15 over 72. Okay? So now I'm going to do my cross product property. Or I could just, again, cross product property is something that we've kind of used a lot. But I'm just instead going to multiply both sides by 8 pi. Okay? And all that's going to do is just keep the 72 where it's supposed to be, because we're eventually going to divide by 72 anyway, and then just isolate measure of arc zy. So that means measure of arc zy is equal to 8 times 15 is 120 pi over 72. Now I know that doesn't mean much to you guys, so we're going to estimate it as 120 pi divided by 72, which is about 5.24. Okay. 5.24 inches. Okay? And that's how we can do that. Okay? I'm going to give you about 3 minutes, and I want you to try and do B on your own. Okay? Try and do B on your own. All right. So what did we come up with?
I got 1.137.
You got 11.137.
No, 1.137.
1.137. 1.13 centimeters.
Yeah.
Okay. Anything else? Do something different? All right. Let's check. Okay. So again, if I want to set up arc length, right, I'm trying to find the measure of arc zy. All right, and a couple things that we want to take away from here. Okay. Here, my diameter is 10 centimeters. Okay. My central angle is 130 degrees. Okay. So if I were to kind of plug, so just again, plugging kind of this in, right, remember that there's two different ways that we can think of circumference. Because again, that's what we're finding. We're finding a portion of the circumference. We can think of it as 2 pi r, or we can think of it as diameter times pi. Okay. In this case, since we're given the diameter, we can just use that, which is equal to 130 over 360 degrees. Now, since our diameter is 10, we can just plug in that information. If we simplify the right-hand side, we get the measure of arc zy over 10 pi is equal to 13 over 36. I'm going to multiply both sides by 10 pi. And I get measure of arc zy is equal to 130 pi over 36, which is approximately 11.34 centimeters. Okay. So we're a little bit off.
No, I actually did everything right. I got 11 to 10. I just multiplied it by pi.
Instead of 10 pi?
10 pi.
It happens.
Yeah.
That's good. So be careful of those little things, guys. Okay? All right. Are there any questions on this? Okay. I'm going to go ahead and stop the video, and I'll be posting it momentarily.